So if you want to find an inverse, you're going to need to switch x and y and solve for y. That's it. And we do that for graphability. Now, we leave it as y equals. We also could write this notation, and we can look at that and say f to the -1 of x, and then we get all crazy with it, and we're like, f to the -1, that means I'm going to put it in the denominator. No. This is just a notation. When I see this just simply means, and it's important because I'm writing it in red, this just means inverse of f. That's it. Okay, so there's no math to do with this -1. Just don't, okay? Let's find the inverse of this. Let's just start with that, okay? So don't make it harder than it is. The original function, write it in black, y equals 3x over 2 is that. And we are going to switch x and y and then solve for y. So let's switch x and y, 3y over 2. And then we're going to solve it for y. Okay, if you were going to solve for y, what would you do? Well, we'll get into more specifics on some harder ones later, but for now, we're just going to double it. That gets that denominator out of the way. And then we're going to, well, divide by 3. So we'll divide that by 3 and divide that by 3. And we now have 2x over 3, and that is equal to y. And that's fantastic. I'm going to go one more step with it because we just found an inverse, so I'm going to call it what it is. This is the inverse, and that inverse is 2x over 3. Okay, now, to be fair, this is the same thing as 2/3 x, and this is the same thing as 3/2 x. It's just a different representation. You don't have to have the x in the numerator. It can float on the side to be multiplied because it's x over 1. And, excuse me, the problem said graph the original function and its inverse. I'm going to graph the original function in blue, and then I'm going to graph its inverse. We're going to do them on the same coordinate plane, and we're also going to find domain and range of each. So y equals 3/2 x. This is the original function. It shall be blue. So y-intercept is 0. Slope is 3/2. Up 3 over 2. Up 3 over 2. Down 3, back 2. Down 3, back 2. There we go. I'm going to connect those. This is the original function. All right, fantastic. Now here's the inverse. Looks like a lot, but it's really just saying 2/3 x. Graph it. Y-intercept 0. Up 2 over 3. Up 2 over 3. You could go down 2. You could go back 3. Down 2, back 3. You're going to have a line. That line looks like that right there. There it is. Okay. So we have just graphed f and f inverse, so I'm going to make sure we know what this is. This is f inverse, and the blue one is f. And then it also says state the domain and range. Domain and range never get old to me, so let's switch to purple just for fun. So I have a domain, I have a range for f, and I have a domain and a range for f inverse. And this is going to be pretty straightforward on this one, but the domain of the f function, the blue one, goes from -infinity to +infinity. And the range of the f function, it goes down forever and up forever, so that's also -infinity to +infinity. F inverse is going to go from -infinity to +infinity. And its domain goes from, range goes from -infinity to +infinity as well. Okay, I'm going to make this look like the chart that it is. There we go. Wow, perfectly straight lines. Fantastic. Okay, that takes care of number 6. And you're like, okay, well, what was the big idea? Now, there are some big ideas coming, and that's going to be in a separate video after we do a few more examples. I think some things are not obvious yet, but they will be. And there's some stuff about the graph that's going to become obvious as we go. So we're going to use this one as a reference as we move on. So let's do the next one. And the next one says f of x equals -2x plus 4. And then step 1, switch x and y. Okay, so we can do that. 2y, -2y plus 4. And then solve it for y. I think this one's running out of ink. That's tragic. All right, we're going to subtract 4 from both sides. We're going to basically reverse the order of operations, and we're going to spend more time talking about how to know when to do what on these, because they get a little bit trickier. Then we're going to divide by -2. cancel both of those. And we're going to have y equals x over negative 2 minus 4 over negative 2. And that's just sloppy. It's right, but it's sloppy. So let's do another rewrite on it. And that final thing right there, basically I divided both of those terms by negative 2, just in case you needed to know. So what I want to do now is f inverse equals, never mind that spot there. We're going to have, here it goes, let's put a 1 there. 1/2 x, but it was negative. But the negative was on the 2. It doesn't matter. The fraction's negative. Negative 4 divided by negative 2 is positive 2. So we now have a function known as f, or y equals, either way. And we have its inverse. And we're going to graph both of them. So let's graph the original function. Slope-intercept form. Don't make it harder than it is. Go up to 4. 1, 2, 3, 4. Slope is negative 2, so down 2 over 1, down 2 over 1. There we go. And we're going to connect those dots. All right, there we go. Let's do the same with this inverse. We're going to go up to 2. And the slope is negative 1/2, so down 1 and over 2, down 1 and over 2, down 1 over 2. And we're going to connect those dots as well. If I'm going a little fast, you can slow the video down. If I'm going too slow, you can speed it up. If I'm going just right, leave it where it is. Okay, there's some observations we're going to start making about these in a few minutes in another video. But you may want to go ahead and start looking at your graphs and seeing what you notice. There's f, there's your inverse. There we go. Graph doesn't look much better. That table doesn't look much better. One of the observations I'd like you to notice, and I'm not going to directly state it, notice that this x-intercept is 2 and this y-intercept is 2. Interesting. Just saying. Just saying. Okay. The original graph, which for me is blue, that would be this one, that's f, and the inverse is red. The original graph has a domain of negative infinity to infinity. It goes to the left forever and to the right forever. It's a little steep, but it works. Goes down forever and up forever. Nothing too exciting about that domain and range. Same with this. The red one goes left forever and right forever and goes down forever and up forever. We have now done a couple example problems with inverses of linear functions. In the next video, we're going to go into some that are not linear.